Hi, it's been about a month since I published my last video. A few personal issues and also some contract work which kept me busy. I haven't really had time to invest in this channel. However, this footage I shot a month ago, and I was going to publish a month ago, but here it is now. So since I haven't published a mailbag video in a month, I have a huge backlog of items to get through. So this is what I currently have, which is about a dozen packages I need to get through, and this is the backlog of stuff that was sent before those packages. So I reckon I'm going to have to probably publish a couple of videos a week, maybe, but let's see how I go. Okay, so the next package. Oh, interesting. What's this? Looks like, is it coffee or something? Feels like coffee. So the eWBM module is essentially an Arduino style or Arduino compatible board with one of the DLS7601K41 LoRaWAN certified modules. That's pretty decent, having a certification for LoRaWAN. And not only that, you don't have to run your own software LoRaWAN stack. So this module is actually quite interesting because it's running not only the SX1276 LoRa module, but also they designed their own SoC that runs, or what's called the MS500. And this particular one runs a Cortex M0, which is clocked at 100 megahertz. It has 4 meg flash, 64K SRAM, and also 8K production ROM. So I think 8K production ROM you probably don't have access to, but this particular module would have the ROM programmed at production time. The SoC also has TRNG, which is something you really need for secure applications. It supports a whole range of cipher protocols like AES-256, SHA, HMAC, RSA, it's a whole lot of them, and also GPIOs. It's got tons of them. There's 4 UARTs, 3 SPI, 4 ITC, SDIO, and just a bunch of plain GPIOs as well. This would be quite nice. They sent me 2 modules. I had a project in mind that I'd be using LoRaWAN, so I think we need to fire these up and see how they go. Let's see if I can actually connect to one of the Sydney-based LoRaWAN networks. Excellent. Okay, so normally when I shoot footage for a video, I add notes as I go, but I didn't this time, so I'll just try and guess what's going on. Since I'm connecting to the Things network, I have to create an account. Actually, I already had one, but anyway, hey. Next, you have to choose which way you want to register to the network. There's either OTAA or ABP. OTAA is the preferred method as it negotiates and creates keys on a regular basis and dynamically. ABP is simpler and really is only good for testing. It's not good for production environments. So if your device supports OTAA, then use that. Okay, so once you've logged in successfully, you need to first create an application. So I'm going to call this eWBM tests. We don't need to worry about that, and just add an application. Then you need to add some devices. So the first way, as I mentioned before, you can either connect to the Things network using OTAA or ABP. Device ID, let's call it the WBM01, and we can change this 1, 2, 3, 4, 5, 6, 7. I think you need to have 8 characters. I think that's right. And then register. Now that you've registered the device, it gives you the device EUI and the application EUI, as well as the application key. So those 3 items are very important for OTAA activation. So if you go to the settings screen, you can see all the important EUI numbers. Some of you are going to comment that I haven't blurred out the application EUI and the keys, so I'm going to delete this application and device, so it doesn't really matter if I show them on my YouTube video. So you can see this OTAA activation method is the default. You can also drop into ABP. Okay, so there's a number of ways of being able to do this. You can either do it programmatically or using standard AT commands. So let's try the AT command set first and see if we can join. Okay, that didn't seem to work. Let's try OTAA. Well, that didn't work either. So let's try whacking this onto an Arduino. Not that it's going to work, because I'm having trouble connecting to the Things network. But let's just see how the Arduino side goes. Okay, so that's a little bit sad. I wasn't able to get this properly connected to the LoRaWAN network within Sydney. I managed to get it connected once and send data back and forth, but after that I wasn't able to connect. Bear in mind that these are pre-release boards. There's going to be a few kinks and issues with it. I believe that I'm the only one within Australia who's actually trying these on the Australian LoRaWAN network. So of course I tried multiple different methods of connecting, changing the SF factor, bandwidth, all sorts of things. I'll certainly be sending the information back to the manufacturers, letting them know the issues I have, and it'll be sorted out hopefully. So anyway, I think I'll move on to the next thing. So my wife's actually a pretty good voiceover artist, but let's see if I can put her off.
This video is being sponsored by JLC PCB, who provides Mick with all his PCBs. They can produce 1 to 6 layer boards from 0.4 to 2 mm thickness, via drill size down to 0.2 mm, track widths down to 3.5 mm, and can handle BGAs, wibbly wobbly things, cutouts, gold fingers and other weird things. You can currently get 5 PCBs for only $2 in any colour, manufactured in 24 hours. Click on the link in the description below to check them out. Mick is also giving away 2 $20 coupons to be used on any JLC PCB purchase. The first 2 people to respond in the comments below will get 1 each.
I can't put you off at all, can I? So while I was actually filming this, yet another package arrived. Now this one comes from PiSupply, which is a UK-based Raspberry Pi add-on manufacturer. Haribo. I probably can't actually eat these because I'm actually celiac, which means that I am allergic to wheat, any gluten. So, but I guess my kids might enjoy those. This was a knife that was sent to me by one of my patrons, and this is absolutely fabulous. I absolutely love it. So they sent through a couple of things, which is a flick. You may have seen this in one of my weekly roundups. And also PiJuice, which is also in one of my weekly roundups. So it has a lithium-ion battery and also power management to be able to control power to the Pi. And I believe it's also got a real-time clock on there as well, so you can power on, power off, and do all those sort of things. So we need to check this one out. Before I do that, I'm going to look at this flick. The flick is essentially a gesture-based board that allows you to control, whatever. It's essentially an input device with capacitive touch. Let's check both of these things out and see how they go. Okay, so the PiJuice is a pretty neat little board. It's essentially an all-in-one power module for your Pi. It's built around a standard run-of-the-mill battery you can pick up from anywhere, your BP 7X, pretty common. So using this battery, PiSupply claim that you can get up to 4 to 6 hours of uptime just running off battery, so that's pretty decent. It's also got an onboard RTC, soft power on-off switch. It drops down to the fairly low power deep sleep modes, which is nice. You can wake it up on alarm set by the RTC. There's a couple of buttons to mash on the side, an RGB LED there as well. So it's driven by an STM32F030 MCU, which provides hardware watchdog and RTC control. There's also BQ24160 LiPo charge management IC, which is a pretty decent little IC. Battery fuel gauge based on the LC709203 and the ubiquitous EEPROM that's required for all Pi hats. And input voltage is from 4.2 to 10 volts, so that's nice. So let's give this a whirl. Okay, so since I've plugged everything into the top connector, I should be able to switch it on by pressing this button. Hopefully. Are you doing anything? That's the button. That button. I should really read the documentation, shouldn't I? So it's all powering up. Let's crack open the console and see what's happening. So when I had the GUI installed and I restarted the Pi, I tried to access the PiJuice GUI interface, but it came up with this particular error. So the CLI couldn't actually read the PiJuice hat for some reason. I2C bus was enabled, and I could actually see it on address 14 hex. So there's nothing wrong with the I2C bus, and I could also dump the information from the PiJuice hat. So there was something strange going on. So then I looked at what was installed from the PiJuice, and there was both a binary and a Python script. And if you use the command file, you can see that both of them came up as both a binary of 32-bit and also a Python script. But when I tried to run the Python script, it came up with this sort of error. Now this is fairly indicative that the file magic number is not being read properly, and it's actually being decoded as a bash script. Okay, so under Unix, a file's magic number is actually quite important because the system will determine what actually has to happen based on that file's magic number. So for example, if we look at the command /bin/ls, you'll see that at least on OS X, the magic number for /bin/ls is feed face, but it's actually feed FACF, which determines whether it's actually 64-bit or 32-bit. So this magic number is determined by, of course, a couple of files. So if you go down to this file, it's got a whole lot of conditions which change and determine what actually ends up being a file's magic number. So you can see that this is a 64-bit OS X mark binary. You can see it the same thing for the command ln. So when we come to a bash script, for example, if I type in this, which is a fairly simple bash script, I can type in this and it tells me that's a born again shell script because it looks at the hash bang. So what this tells the Unix system is the hash bang, it's going to execute the command after that until a carriage return and then feed into /bin/bash the rest of the script. So in this case, the Python script was actually being read as a bash script. So this was simply resolved by typing in Python 3 and then a script. So I'll start off first with the battery removed and see how much power it uses up. So my USB logger, of course, can't recognize anything lower than, I think it's 100 milliamps, and that's pretty much what it's doing at the moment. It's not really picking up anything. So that's with the Raspberry Pi powered off. Of course, as soon as I turn it on, it's going to start ramping up to ridiculous amounts. Yep, which it's doing. And so once it's finished booting up, I'll shut it down again, the Raspberry Pi into standby mode, and see how much power it consumes. It should be consuming probably about 100 milliamps or 200 milliamps. Okay, so I've powered off, and yep, it's gone back down to 100 milliamps, which is pretty good. So let's whack the battery in and see how much extra juice it takes up. So it's gone back up to 600 milliamps, 700 milliamps, which is a fair amount. That's actually quite surprising that it's pulling that much. Maybe it's trying to charge the battery and see what state it's in, possibly, but it's 100%. Shouldn't really be using that much. So that's looking pretty good. So one thing I haven't actually looked at is powering it from these headers, so you can chuck on external power. You don't need to power it from this USB port. There's also extra GPIOs which you can fire up and use. I think, all in all, this is actually a nice little unit if you want to be able to power your Pi completely. So I think I need to get on to the next thing. Okay, so let's try this flick out and see how well this goes, since we've got this Raspberry Pi all powered up. Okay, so PiSupply have a simple setup script that does everything for you, or supposed to do everything for you. But it's a fairly simple script, so I might just run these commands manually, I think. A couple of people have run into a few issues installing the Flick Python libraries. You tend to get a lot of errors about attribute error none type, but Python 3 seems to do the trick. If you can install Python 3. And yes, the lack of me reading documentation has caused me to wire up the board incorrectly, but I managed to correct it. Didn't do any damage, which is nice. But now I can see the Flick board on address 42. So I should be able to run the Flick demo, and there we go. Look at that. So hopefully I'll be able to get some sort of response out of it. Oh, look at that. Excellent. So that's XY coordinates, which is nice. Theoretically, I should be able to see distance. So it should be able to pick up a fair distance away from the board, as well as touch. So interesting product, really. The sensitivity is interesting, to say the least. So I should be able to flick east to west, so that actually works. North south, that works. Does it work diagonally? East, yeah, sort of. Touch, yep. I can tap. No, I can tap. Yeah, there we go. I'm not sure how to double tap. It sort of works sometimes if you just keep pressing it. So I was going to use this Flick as the basis of a video editing desk, and hopefully it was going to be able to provide some sort of feedback so I can have a virtual jog shuttle. But I might have to play around with it a bit more and see if I can get a better response out of it. The response so far isn't incredibly accurate. However, that might be because I do have a lot of mains power running around this particular area, so it may be generating a bit of interference, especially with these long cables. So if I have shorter cables, a bit more grounding around this plate, it might actually be a lot better. Okay, so I've moved things around slightly and moved a couple of lights which may have been causing a bit of interference. So I'm getting nothing now, which is good, but I've discovered I can do an air wheel. It's basically this. So you can see it's actually picking it up now, which is nice. The Flick is really quite sensitive to any RF around the place. If you've got stray main signals, anything that's emitting some sort of EMF, it's going to cause issues with it. So I think I should move on. I've seen enough of this to know it looks promising. There's a few sort of bugs with it, but I think if I spend a bit of time on it, I might be able to get this working quite reasonably. So I think next thing. So every so often I manage to find a dumpster with some really cool stuff. And I found a dumpster the other day which had this. So if you're in the lighting industry, you'd probably recognise this straight away. This is a colour and pattern wheel that allows you to change various colours on this side and various patterns. You can sort of see the different patterns you can get. There's various steppers, and one for controlling the pattern, colour, and also the focus. I mean, it's not particularly interesting apart from the fact that it's got some really nice juicy stepper motors on it, which is good. So that was a good find. I just hope that a lot of these steppers do actually work. Some actually look a little bit burnt out, but yeah, that's quite interesting. However, this wasn't really the most interesting thing. The best thing was finding a whole bunch of these things. So if you saw one of my earlier mailbags, you would have seen me find a bunch of these. These are motorized sliders for sound desks, and I found even more of them. So this is absolutely fabulous. Who knows what state they're in? So one thing I was going to do with those previous sliders is make a PCB that I could actually connect these to and control them either through possibly RS485, more than likely I2C and UART. So that's even more incentive to be able to make a PCB for those things. And I might actually sell these on Tindy as well. So that's a heck of a lot of sliders. Anyway, that about wraps it up for this mailbag. Thanks for watching, and see you next week. You got to read it straight, okay?
Okay, but I can't see it.
Okay.
No, because this is in the way.
Oh, why is that in the way?
So you can't see me.